starting a new unit, finally. Now that we're done with like reviewing a little bit and calculator stuff. And the first thing we're going to do is we're going to find where graphs have relative min. So minima is like the Latin. I would just call it relative min, so they'd be test. Relative max. And we're going to find out where functions are increasing and decreasing. So let me give like short notes here, and then we'll do the problems like below that. So f of x is increasing when f prime of x is blank. F of x is decreasing when f prime of x is blank. Flip from increasing to decreasing is a blank. And a flip from decreasing to increasing is a blank. Can you write? Kind of?
Yeah.
You good? Oh, there's a cross country something today. Is that why those three are?
Yeah.
The guys didn't go there? You what? He likes the girls better. Seems fair. Okay. F of x is increasing when f prime is. Hopefully you guys can tell me that. If the derivative is blank, then what? Then f prime is then f is increasing. Yeah, positive. So if the slope is positive, so we get into this like there is a big difference between the two words positive and increasing. Positive just means above zero. Increasing means getting larger. Those are two very different words, and they're not interchangeable, and you have to be able to use them correctly. So just as an example, my bank account could be positive and decreasing, right? My bank account could be negative and increasing. I mean, I think you guys know what those words are. You just got to be careful with how you use them because they do represent different things. So when the derivative is positive, that means positive slope, right? That means your original function is increasing. If the derivative is negative, that means a negative slope. We're going down, so that means the original is decreasing. If we split from increasing to decreasing, so we get like the top of a hill, something like that, that's a relative max. That means relative to all the points around it, it's the highest. Relative max, relative top, relative peak. So relative to the rest of the points, like this little area here, that's the highest point. A flip from decreasing to increasing is a relative min. So that would be like the bottom of a hill. So relative to the points on either side of it, that's the min. And you might have like several relative max and mins in a graph. So you don't have someone like that. We got a relative max here, relative min here, relative max here, relative min here. You could have like multiple, like a sine and cosine graph. You've got an infinite number of relative maxes and relative mins. It's just hills over and over and over. All right, so let's start doing one of the problems and kind of look at that stuff with it. So the first one, they gave me basically y equals negative 1/2 x squared. I'm just putting it into y as x's. Minus 3x minus 11 over 2. And so your job is to find these four things. Where's it increasing? Where's the function increasing? Where's the function decreasing? Where's our relative max? Where's our relative min? So we're going to start by taking the derivative. Because if I want to know where something is increasing or decreasing, that means I want to know the slope. And how do I get to the slope level? Take the derivative. So the derivative here would be negative 1x minus 3. I'm going to set that equal to 0. And I'm going to solve. So in this case, I get x equals negative 3. That is what's called a critical point. A critical point is where the top or bottom of f prime of x equals 0. So if this was a fraction, if this were a fraction, we would set the bottom equal to 0 too. And I think there's a couple of those in here, so we'll definitely look at one of those. So x equals negative 3 is a critical point. So now what you're going to do is make a little number line. So I'm going to put negative 3, I'm going to put 0 on the number line always. I'm going to put negative 3 on there. But 0 isn't really, no, I'm not going to put 0. I'm just going to put negative 3. That splits my graph into two sections, right? Like to the left of negative 3 and to the right of negative 3. So that gives me two intervals, negative infinity to negative 3, which is this part over here, and then negative 3 to positive. Because this is the critical point, it won't change from increasing to decreasing anywhere else except at that point. And it might not change at that point, but that's the only possible place it can change. So like if the function is decreasing at negative 4, that's in this interval, it's also decreasing at negative 10 and negative 900 and negative 9 million. Like whatever it's doing in this interval, it's doing in that entire interval. The same thing over here. So what we're going to do is pick a point in this interval, whatever you want. It doesn't matter, because if it's decreasing at one point in this interval, it's decreasing at all. So I'm going to pick the easiest one for me to work with. So maybe negative 4. Don't pick negative 3, because that's not really in the interval, you know? It's like the divider. So let's say I pick negative 4. So y prime at negative 4 would be negative 1 times negative 4 minus 3. I don't even really care what the number is. I just care if it's positive or negative. So does that derivative, when I plug in negative 4, come out positive or negative? It comes out positive, right? So it'd be like positive 4 minus 3. So y prime is greater than 0. That means f of x is increasing. So I'm going to go back up here, and I'm going to put increasing on that portion of the number line. But we're going to build this number line a little bit as we go. We'll add more and more things. Like we'll start putting stuff on the bottom of it too. All right, I'm going to do the same thing in this other interval. So pick a point between negative 3 and positive infinity, whatever you want it to be. So I would use 0, just because that's the easiest one for me to look at, in my opinion. So y prime is going to be negative 1 times 0 minus 3. So then we get negative, so y prime is less than 0, which means f of x is decreasing. Then I'm going to put decreasing on my number line. So I know the function increases all the way up to x equals negative 3 and decreases after. And we've got a graph, right? Like we can check it. I mean, negative 3 is right there. So doesn't the function increase all the way up to negative 3 and then decrease after? That's all we're finding. That also gives us, and I'm kind of out of room here because of the notes, but if the function switched from increasing to decreasing, does that create a relative max or a relative min? It creates a relative max. So I've got a relative max at negative 3 comma, and now that's a point on the original graph. So am I plugging into the derivative to find the slope at that spot, or the original to find the y value at that spot? The original to find the y value. So derivative tells you slope, original tells you y value. So if you plug negative 3 into that, and you guys will have your calculators on this. Like, I'm done making you do stuff by hand for right now, so you can take derivatives with your calculator, you can plug in with your calculator, you can do whatever. So it'll get us through this stuff a little faster. But let me just like work through it. So this would be negative 9 over 2 plus 9 minus 5.5. So negative 1, I believe. And that's really the like what we're going for in the end is, okay, what's the relative max, what's the relative min? All that work prior was to kind of establish that. Questions on that one? I don't think they're too bad, but it might take a while to kind of get used to them. I think before we do another one, I think I can go over. Yeah.
When you put the parentheses around negative infinity and negative 3 and then negative 3 to infinity,
yeah.
Is it going to be hard brackets anywhere, or is it just something?
No, it can't be hard brackets because the negative 3, so the function is not increasing or decreasing in negative 3. It's flat. So you can't include negative 3 in either of those. Okay. And then infinity and negative infinity, you can never put a bracket in. Okay. All right, let's do, yeah.
The critical point on the bottom of x equals, is that 0 or is that negative?
That is 0.
Okay.
So we'll do one with the fraction too, so we can any more room. All right, let's do the second one. So they're giving me y equals x to the third minus 3x squared plus 2. And you have graphs today, right? I mean, I can tell the function is going to increase up until here, so I should get something at 0. And decrease here, so I should get something at 2. That's going to increase. Like, I kind of know what the answer is, but that's not really the point. So the first thing you do is take the derivative. So y prime equals 3x squared minus 6x. I would have set that equal to 0. If there were a bottom, I would set that equal to 0 also. So when we get into like quotient rule, we'd have to set the bottom equal to 0 also. But here there's not, so I'm just setting that equal to 0. So I can factor out a 3x, give me 3x times x minus 2 equals 0. Which should give me x equals 0, and x equals 2. Go to your number line, put your critical points on there. So 0 to 2, and that. So now we have 2 critical points, which splits the graph into 3 parts, right? Like if we had 4 critical points, that would split the graph into how many parts? 5 parts. It's always like one more than however many tick marks you put on there. So negative infinity to 0. 2 to infinity, and we're just testing. So from negative infinity to 0, it's either increasing the entire time or decreasing the entire time. Doesn't matter which point I pick, I'm just going to pick one. And you got choices now where you plug back into. So you can plug back into like that version of the derivative or that one. I think the bottom one's probably easier because you can just like if I plug, let's say, negative 1 into there, plug negative 1 in here, does this part of the multiplication problem become positive or negative? Negative. Plug negative 1 in here, negative. So negative times negative gives you a positive. So y prime is greater than 0, which means y is increasing. So increasing on that section of the number. So 0, 2, so let's plug in, say, 1. If I plug 1 into 3x, this part comes out positive. If I plug 1 in here, it comes out negative. So positive times negative gives me a negative, so the derivative is less than 0, which means y is decreasing. So the negative slope means the original is going down. Same thing here, plug in whatever you want, let's say 5. So that would make the 3x positive. It would make the x minus 2 positive also, right? So positive times positive. So y prime is positive, which means y is increasing. So my graph goes ink, deek, ink. So we kind of start to visualize that up, down, up, which is what we have, right? We have up, down, up. And then I need to find the points. So if I switched from increasing to decreasing, that's a relative increase and the decrease, the relative max. So I have a relative max at 0, comma, and where am I plugging back into to find this value? The original. So if you plug 0 into the original, you just get 2. And then if I switched, if the original switched from decreasing to increasing, I have a relative min at, and it switched at 2, like right at this spot here. So it's at 2, comma, something. So again, plug that back into the original. So that'd be 8 minus 12 is negative 4. So that should be negative 2. Then if you look at our graph, so at 0, 2, we have a relative max. And at 2, negative 2, we have a relative min. So we increase up until the max, we decrease to the min, and we increase after. Questions about that one anywhere? Seem all right? All right, let's do one with a fraction. And then get you guys going on the rest. Let's say 4. If there is a fraction, I'm going to worry about asymptotes also. I don't have asymptotes when there's no fraction, but if there's a fraction, I'm also going to look at, part of this is just review, part of it matters for what we're doing too. You have the graph, which is obviously going to help you, but are there horizontal asymptotes on this graph? And if so, where? And why? Someone has to speak. Horizontal asymptotes, what do you look for? The what? If you have the graph. Now what do you look for? In the fraction. Higher power. Where's the higher power in this fraction? On the bottom. That means there's a horizontal asymptote at y equals 0. So the horizontal asymptote at y equals 0. Vertical asymptote. Vertical asymptotes happen when bottom equals 0 and the top doesn't. So I don't really have to worry about the top being anything here because it's just a number. But when the bottom equals 0, I have a vertical asymptote. So t squared minus 1 equals 0. T plus 1, t minus 1 equals 0. So t equals negative 1, t equals 1. So I do have 2 vertical asymptotes. That's going to matter a little while. So this is kind of like, I break this down like we're going to look at, because we're going to do the second derivative in a couple days too. Here's the information from the original graph, or the original equation. Horizontal asymptote, vertical asymptote. Then I'm going to take the derivative. That tells me where the function is increasing, decreasing, relative max, relative min. Then I'm going to take the second derivative. That's going to tell me something else too. So concavity is what we're going to get into. So I'm kind of thinking about this as 3 parts. Every graph has 3 levels. Original, derivative, second derivative. So that's the information from the original. From the derivative, well, the original equation is negative 3 over x squared minus 1. We could do this 2 ways to take the derivative. Well, 3 now, actually. I could do chain rule. So I could bring it up, like bring the bottom up and do chain rule. I could do quotient rule. Or I could put it in my calculator, because I'm going to let you guys use calculators. Let's put it in our calculator just to review that, because it's been like a week since we had class. Take the derivative of that in your calculator. See if you can still do that. So here's what you type in. You can see all this. This is what you're typing in, and this is what you should get at the end. So the F3 calc is differentiate. I typed in the equation. How the x, because you tell the calculator what variable. I swear someone, was it you that needed a calculator? I got one. You what? I'm going to want you to go turn it into the library, but not right now. So like after the lecture, you're going to go and check that one back in and check this one out. Yeah. Let me hold up. Let me put these together. Over the like barcode. I should have batteries. Yeah. Yeah. So that little sticker doesn't fall off. Here I have functional batteries, so you can try these and see. Oh crap, that was my, I needed that. What's the derivative?
6x over x squared minus 1 squared.
That's what it tells you, right? Everybody get that? Everybody need help on the calculator getting to it? Did yours work now? Okay. So give my batteries back at the end of the hour. I'll call my batteries. Okay. So this is where we have set the top and the bottom equal to 0. If there's a fraction, you set the top and the bottom equal to 0 and go from there. So if I set the top equal to 0, that gives me x equals 0. If I set the bottom equal to 0, we've talked about this before, but this power over here essentially means nothing because how would I get rid of it? Square root both sides, right? Well, if you square root this side, the square goes away. That's great. If you square root 0, what happens? Still 0. So you essentially have x squared minus 1 equals 0, which we've already solved. We did it with t's, but this gives you x equals plus or minus 1. So I'm going to put all the points, these are all critical points, 0, plus or minus 1. I'm going to put them all in the number line. Then that gives me, so now I have 3 critical points, which means I have 4 intervals that I need to test. So negative infinity to negative 1, negative 1 to 0, 0 to 1, 1 to infinity. And where am I plugging back into? What level? The original or the derivative? I'm plugging into the derivative because the derivative tells me slope, which will tell me whether we're increasing or decreasing. So you always plug back into the level that you just came from, basically. So if I'm working in the first derivative, I plug into the first derivative. When we get to the second derivative, you're going to plug into the second derivative. So say I plug in like negative 2. Well, the nice thing about these, about this one especially, if I plug negative 2 to the top, positive or negative? Negative. It doesn't matter what I plug into the bottom. It's going to be positive, right? Because you're going to square it. So negative divided by positive, so this means y prime is negative, which means y is decreasing in that section. Same idea here. So you do have to plug in a fraction, but it's not like you have to know that answer. You just have to know if it's positive or negative. So if I plug in like negative 0.5, the top is negative, bottom is positive. So, I mean, it's a decimal, yeah, but that doesn't really make my life that any harder. So the derivative is still negative, so y is still decreasing. So this is an example. So these points are possible relative max and relative mins. Is negative 1 a relative anything? If it switched from decreasing to decreasing, that's not like the top or bottom of the hill, right? That's just down and then down more. The reason it's not is because it's already a vertical asymptote. So if we go up here, negative 1 was a vertical asymptote. It can't be a point that's bigger or smaller than other points if it's not a point. It's an asymptote. So it's already like, got a job. It's not. Hello there. So even if this went decreasing to increasing, it couldn't be a relative max or relative min because it's already an asymptote. So an asymptote like overrules that. All right, 0 to 1. So let's say I plug in like 0.5. Now I'm at the top positive. Bottom's always positive. So y prime is positive, which means y is increasing. So do I have a relative anything at x equals 0? I do. I have a relative min because it does switch, and 0 is not an asymptote. So that is an actual point that I can put on my graph. This last section, 1 to infinity, so let's say I put it at like 5. Top and bottom will both be positive, so y prime is greater than 0. So y is increasing. Do you have a... So our job is to find increasing and decreasing, which we've done, and then relative max and relative mins. So I just kind of look at my number line, decreasing and decreasing, that's nothing. But again, even if it did switch here, it would switch at -1, and that can't be a relative max or min, so it's a vertical asymptote. At 0, we do have something. So I have a relative min at 0, comma, I'm going to find that in a second. And then at 1, we have nothing because it's increased to increase. So relative min at 0, comma something. How do I find the something? Which level do I plug back into? The original. So if I plug 0 into the original, I'll get -3 over -1. So 3. So I have a relative min at 0, comma 3, which is that point right there. How are we doing? What can I help with? What can I go over again?
Real quick, I did the minimum calculation on the graph in the calculator in the 89.
Okay, that is taking the calculator a little too far right now. I mean, I don't care if you do it to check, but you gotta let it do it by hand too, you know.
Oh,
But fair enough. What's your question?
It didn't give me 0. It gave me like -6 times 10 to the -8. Am I allowed to assume that's practically 0?
Yeah. So it's using some weird algorithm that somehow doesn't get to exactly 0, but gets infinitely close, basically. Yeah.
Okay. Just making sure.
And I told you 3, right? Or did I tell you like 2.99999 or something?
Perfectly fine.
Oh, really?
It just the x value was screwed.
Interesting. Other questions? Josiah, you good?
Yeah.
All set? Alright, the rest of it's for you. So you got there's 7 more. You got a long time. So let's work on these. This is a hugely important thing. Like a ton of stuff that you do for the second semester is taking the derivative, finding increasing decreasing. So we get into like story problems now. So find where the rate of water is increasing. Find where the level of this is decreasing. So this is like a hugely important thing for applying the derivatives, which is what second semester is. Keep rocking. Yeah, so go turn yours in, but then bring it back to me if they'll let you. Sometimes they're afraid they're going to steal it, so they'll want to keep it. And then check the other one.
Do you have an extra copy of those plugin derivatives?
Yeah. So I tried